Here are the best photos of our solar system through the last 12 decades. Jupiter. This striking view of Jupiter's Great Red Spot and turbulent southern hemisphere was captured by NASA's Juno spacecraft as it performed a close pass of the gas giant planet on February 12, 2019. NASA JPL Caltech's REMSSS Kevin M. NASA spacecraft and telescopes have captured stunning photos of the solar system for decades. The first image taken in space came from a rocket camera in 1946. Before that, astronomers took black and white images of celestial objects using telescopes on Earth. If you were a kid in the 1960s, you grew up with the first images taken on the Moon. Since the 1970s, spacecraft have been visiting the solar system's distant planets, returning photos of turbulent atmospheres, colorful rings, and bizarre moons. Here are the best photos of our solar system through the last 12 decades. For decades, scientists have pointed earthly lenses toward the sky to capture images of the cosmos. Even the earliest rockets that launched off the planet brought cameras into space. At first, our photos of the solar system came back grainy, unclear, and colorless. The very first image taken in space, for example, came from a 33mm motion picture camera that American scientists strapped to a captured German rocket and launched off Earth at the end of World War II. The camera fell back to Earth and shattered, but the film survived. Other early solar system images came as NASA and the Soviet Union explored the Moon for the first time. People born in the 1950s and 60s grew up with the iconic photos of the first astronauts walking on the Moon. Since then, increasingly sophisticated missions have ventured farther into space with better and better cameras. Kids in the 80s got the first up-close images of Saturn and Neptune, while children today are accustomed to high-quality colorful shots of the deserts of Mars and swirling clouds of Jupiter. Here are the best photos of our solar system from the decade you were born. For centuries, humans could only see the solar system through telescopes. At the dawn of the 20th century, astronomers captured fuzzy, black and white images of the planets. This photo of Jupiter was taken in 1906. Jupiter 1906. Astronomer E. Barnard took this photo of Jupiter using the Yerkes Observatory's 40-inch refractor telescope in 1906. Special Collections Research Center, University of Chicago Library. Comets were a popular subject for astronomers working with early photography techniques. In 1907, this comet was captured streaking across the night sky. Comet 1907. A photo of the Daniel Comet, also known as C1907L2, taken with the Bruce 10-inch photographic telescope at the Yerkes Observatory, August 21, 1907. Special Collections Research Center, University of Chicago Library. Saturn and its rings also made for a pretty picture, as in these telescope images from 1916. Saturn 1916. A stereograph of Saturn, copyrighted by the Solar Observatory at the Carnegie Institution. Library of Congress. Solar eclipses were good fodder for early astronomical photos, too. The solar corona is visible behind the Moon in this 1922 image of a total solar eclipse. Solar Eclipse 1922. This photograph was taken on the Lick Observatory expedition to Isle Downs, Australia to record the total solar eclipse of September 21, 1922. Special Collections Research Center, University of Chicago Library. Astronomer Clyde Tombaugh discovered Pluto using these images on glass plates in 1930. Tombaugh saw Pluto's movement by blinking the plates back and forth on a machine that compared astronomical images. Pluto discovery. Tiny arrows show Pluto's movement against background stars in this copy of sections of the original glass plates on which Pluto was discovered. Lowell Observatory Archives. Much closer to Earth, a bright eruption of plasma on the Sun was captured in this 1931 photograph. Sun Solar Prominence 1931. A solar prominence shoots 280,000 miles into space in this photograph taken at Yerkes Observatory. Special Collections Research Center, University of Chicago Library. The first photo of Earth from above came from a jerry-rigged rocket. On October 24, 1946, scientists strapped a 33mm motion picture camera to a captured German V-2 rocket and launched the whole thing into space. First photo from space, Earth 1946. The first photo of Earth from space, taken with a 33mm motion picture camera on October 24, 1946. U.S. Army White Sands Missile Range, Johns Hopkins Applied Physics Laboratory. After reaching an altitude of 65 miles, the camera fell back to Earth and shattered, but the film survived. The Soviet Union launched the space race with its 2 Sputnik satellites in 1957, though those missions did not return photos. The Soviets did, however, capture the first image of the far side of the Moon using the Luna 3 spacecraft in 1959. The first image of the far side of the Moon, taken by the Soviet Luna 3 spacecraft in October 1959. NASA Soviet Space Agency. Our first photos of Earth from the Moon came from NASA's lunar orbiters in the mid-1960s. Old Earthrise Moon Lunar Orbiter 1 NASA. The first image of Earth from lunar orbit, taken by NASA's Lunar Orbiter 1, August 23, 1966. NASA. This first image of Earth from lunar orbit languished in storage for decades, since 1960s technology couldn't fully process the tapes. Read more. Humanity's first photos of Earth from the Moon would have been thrown away if not for 3 people in an old McDonald's. The famous Earthrise photo revealed an entirely new perspective of Earth. Apollo 8 astronaut William Anders snapped it as his team became the first people to circle the Moon in 1968. Earthrise 1968. The Earth rises above the lunar horizon in this telephoto view taken from the Apollo 8 spacecraft, December 22, 1968. NASA. When they saw Earth peering over the lunar horizon, the astronauts clamored for cameras. The other 2 guys were yelling at me to give them cameras. I had the only color camera with a long lens. So I floated a black and white over to Frank Borman. I can't remember what Jim Lovell got, Anders said in an interview for a BBC documentary. And we started snapping away. The decade culminated in the first moon landing. Astronauts Neil Armstrong and Buzz Aldrin left their boot prints in the lunar dust on July 20, 1969. Moon landing. Apollo 11 astronaut Buzz Aldrin walks near the lunar module, July 20, 1969. NASA newsmakers. Exploration of the lunar landscape continued into the 1970s. Apollo astronaut Moon 1971. Astronaut James B. Irwin works at the Lunar Roving Vehicle during the Apollo 15 mission. This photograph was taken by astronaut David R. Scott. NASA. As the Apollo program ended in 1972, NASA shifted its attention to more distant destinations. Moon. Astronaut Harrison H. Schmitt stands next to a boulder during the final Apollo mission, December 13, 1972. NASA. NASA's Viking orbiter took the first up-close pictures of Mars as it entered the planet's orbit in 1976. Mars Ice Cap Viking. This digital mosaic image from NASA's Viking Orbiter 1 shows Mars' residual ice cap, cut by spiral-patterned troughs that expose layered terrain, and surrounded by broad flat plains and large dune fields. NASA JPL uses. The next year, NASA launched the twin spacecraft Voyager 1 and 2 to explore the furthest reaches of the solar system and eventually enter interstellar space. In 1979, Voyager 1 approached Jupiter and sent images of the gas giant back to Earth. Voyager 1 recorded its Jupiter approach over 60 Jovian days in 1979. NASA JPL. For the first time, scientists could see the zones of the planet's atmosphere up close. One of Voyager 1's best shots shows Jupiter's Great Red Spot along with 3 of its largest moons. Jupiter moons Voyager 1. Io stands out against Jupiter's disk, Europa lingers to the right, and Callisto lurks in the shadows at the bottom of this photo taken by Voyager 1, February 5, 1979. NASA JPL. In 1980, Voyager 1 beamed back the first images of Saturn. As the spacecraft passed the ring planet, it photographed Saturn's moons for the first time and led astronomers to discover 3 moons they hadn't previously known about. Saturn moons 1980. Saturn and 2 of its moons, Tethys above and Dione, were photographed by Voyager 1 on November 3, 1980, from a distance of 13 million kilometers, 8 million miles. NASA JPL. Since then, astronomers have discovered a total of 82 moons orbiting Saturn. 20 of those were just found last week. In 1986, Voyager 2 reached Uranus. It photographed the blue sphere of the planet's hydrogen and helium atmosphere for the first time. Uranus Voyager 2 1986. An image of Uranus taken by the spacecraft Voyager 2 on January 14, 1986, from a distance of approximately 7.8 million miles. NASA JPL. Voyager 2 launched before Voyager 1, but it passed Jupiter and Saturn after its twin, since Voyager 2 was on a different path toward these outermost planets. In 1989, Voyager 2 visited Neptune in the cold darkness of the solar system's distant reaches. It is still the only spacecraft to have visited Uranus and Neptune. Neptune Voyager 2 1989. A Voyager 2 view of Neptune taken August 31, 1989. NASA JPL Caltech Kevin M. Gill. As it approached Neptune, Voyager 2 snapped this unprecedented photo. The spacecraft then went on to follow Voyager 1 out of our solar system, into interstellar space. Neptune. Voyager 2 photographs Neptune's great dark spot and its companion bright smudge from 4.4 million miles away, August 1989. NASA JPL. Kids born in the 1990s grew up with far more detailed images of some of Jupiter's moons, thanks to NASA's Galileo spacecraft. That mission also approached an asteroid for the first time in history and returned photos from a second asteroid encounter, with a space rock called Ida, on August 28, 1993. Asteroid Ida Galileo. This view of the asteroid 243 Ida is a mosaic of 5 image frames acquired by the Galileo spacecraft at ranges of 3,057 to 3,821 kilometers, 1,900 to 2,375 miles, on August 28, 1993. NASA JPL. In 1996, Galileo returned this otherworldly image of Io, the most volcanic body in the solar system. It's the highest resolution photo of this moon of Jupiter's to date. Io Jupiter Moon. To compose this portrait of Io, NASA's Galileo spacecraft merged color images acquired on September 7, 1996 with higher resolution images acquired on November 6, 1996. NASA JPL University of Arizona. Galileo orbited Jupiter and its moons for almost 8 years, snapping close-ups like this one, which shows the icy crust of the moon Europa in 1997.
The spacecraft discovered that Europa likely conceals a vast global ocean beneath its surface. Europa surface ice. The thin, icy crust of Jupiter's moon Europa, blanketed in ice particles from a crater 1,000 kilometers (620 miles) away. Minerals from water vapor paint the unblanketed surface a reddish brown. The colors in this picture were enhanced for visibility. NASA JPL University of Arizona. By 1999, a space telescope called the European Solar and Heliospheric Observatory (SOHO) was taking detailed photos of the Sun in its plasma eruptions. Sun solar eruption. A huge, handle-shaped prominence erupts from the Sun in an image taken by the SOHO spacecraft's Extreme Ultraviolet Imaging Telescope (EIT) on September 14, 1999. As the NASA SOHO, the new millennium brought new NASA missions like Cassini, which explored Saturn and its complex system of rings and moons. The probe beamed back this portrait as it approached the planet in May 2004. Saturn. By this point in Cassini's approach, Saturn was large enough that two camera images were required to capture an end-to-end view of the planet and its rings. This composite combines those two images. NASA JPL Space Science Institute. Cassini imaged Saturn's rings like never before as it entered the planet's orbit in June 2004. Saturn rings Cassini. Cassini captured this natural color view of Saturn's rings from below on June 21, 2004, at a distance of 6.4 million kilometers, 4 million miles, from Saturn. NASA JPL Space Science Institute. As it swung around Saturn, Cassini also snapped photos of Hyperion, the weirdest-shaped moon in the solar system, in 2005. Hyperion Moon Saturn Cassini NASA JPL PSTLP. Saturn's small, heavily cratered moon Hyperion, September 26, 2005. NASA JPL Space Science Institute. Cassini captured this stunning photo of Saturn's moon Enceladus in 2008. The spacecraft discovered that jets of water and ice shoot into space through cracks in Enceladus' icy surface. Enceladus. On October 9, 2008, just after coming within 25 kilometers, 15.6 miles, of the surface of Enceladus, Cassini captured this stunning mosaic as it sped away. NASA JPL Space Science Institute. Learn more. The ocean on Saturn's moon Enceladus contains the building blocks of life, NASA data reveals. If you're not as far, congratulations. The 2010s have featured the most stunning photos of our solar system yet. Spacewalk International Space Station cosmonaut Sergei Ryazansky. Russian cosmonaut Sergei Ryazansky takes a break during a 6-hour spacewalk on the International Space Station, August 22, 2013. Johnson Space Center. The New Horizons spacecraft took the first up-close snapshots of Pluto as it flew by in 2015. The probe launched toward Pluto and the asteroid belt at the edge of our solar system in 2006. Pluto New Horizons. 4 images from New Horizons were combined with color data from the spacecraft to create this enhanced color global view of Pluto. Jet Propulsion Laboratory NASA Johns Hopkins University Applied Physics Laboratory Southwest Research Institute. Jupiter's turbulent clouds are still fodder for colorful, dynamic photos. NASA's Juno mission to study the planet's atmosphere and structure launched in 2011. It will continue returning photos, like this one from 2017, until it flings itself into the planet to end its mission in 2021. Jupiter. This enhanced color image of Jupiter's bands of light and dark clouds was created by 2 citizen scientists using data from the camera on NASA's Juno spacecraft. 3 white storms known as the String of Pearls are visible near the top. Enhanced image by Gerald Eichstadt and Shonda Oran, CC by NCSA, based on images provided courtesy of NASA JPL Caltech 3 MSSS. The Mars Reconnaissance Orbiter, which entered the Red Planet's orbit in 2006, offers bird's-eye views of the planet's desert landscapes. This shot of wind-swept formations was taken in September of this year. Mars Crater Sand. An image from the Mars Reconnaissance Orbiter shows sedimentary rock and sand within a 42-mile wide impact crater on Mars. NASA JPL Caltech University of Arizona. The orbiter's best images have come in the last decade, as scientists zero in on the most interesting places on the Martian surface, such as this field of carbon ice photographed in 2011. Mars Carbon Dioxide Ice South Pole. Near Mars's South Pole, it stays cold enough for frozen carbon dioxide to stick around all year. NASA JPL Caltech University of Arizona. The orbiter even captured this enhanced color shot of a freshly formed crater on the Martian surface in 2013. Mars Crater. This impact crater is about 100 feet, 30 meters, wide and is surrounded by a large, Rate blast zone in this footage taken by NASA's Mars Reconnaissance Orbiter on November 19, 2013. The crater was likely formed by an impact between July 2010 and May 2012. Reuters, NASA, JPL, Caltech, University of Arizona. Of course, there's no place like home. A growing system of satellites offer detailed images of Earth with increasing accuracy. Even as we expand across the solar system, scientists are still working to understand our home planet. Planet Earth photo North South America GOES 16 NOAA Abbey full disc low res January 15, 2017. A view of Earth taken at 1:07 p.m. on January 15, 2017 by the GOES 16 satellite.